Good evening once again, viewers. Today I want us to tackle some very few questions on quantity of electricity. This is the second part of my coverage on electrochemistry. So we have this question, the first one. We've been asked, in electrolysis, a current of 200 amperes was passed through a sulfate of metal Q for 58 minutes and 64.8 gram of metal deposited. Determine A, the charge of the metal, B, the volume of oxygen gas produced. And then we have those figures on the bracket. We have Q. The relative molecular mass of Q is 27. 1 Faraday is 96,500 coulombs. Molar gas volume is 22.4 decimeter cube. So before we begin this, there are some very few concepts that I'd like us to note. Number one is that current is measured in amperes and the unit is I. Time is measured in seconds and we just give them the units in seconds. So given this question, I normally advise students first to write down whatever things that we've been stated for. So one, we've been told that a current of 200 amperes, meaning that is I, is equal to 200 amperes, was passed through a sulfate of metal Q for 58 minutes. Therefore, time is equals to 58 minutes. The first thing a student should do is to convert it into seconds. And if you multiply 58 times 60, it will give me 380 seconds. So that is the first step you need to take. Secondly, we have been given I and we have time. We can get Q. Q is the quantity of electricity, and the formula for getting Q is equals to IT, which will be equivalent to 3480 seconds times 200 amperes. So if we multiply 3480 times 200, it will give me 696,000 coulombs. So that is the quantity of electricity that will be required for this mass to be deposited. So if I have that in mind, it will let me know that this quantity of electricity, this 696,000 coulombs, is required to deposit 64.8 grams of the metal Q. But keep it in mind that Q, the relative molecular mass, is 27. It means that 1 mole of Q measures 27 grams. It therefore means that I can get the quantity of electricity that will require 1 mole of Q. It therefore means that I can say, how about 27 grams? Meaning 1 mole of Q will require what quantity of electricity? It will be 6,000 times 27 divided by 64.8 grams. That one will automatically give me 290,000 coulombs. 290,000 coulombs. So if I have this one in mind, this is the quantity of electricity that 1 mole of Q will be deposited. Now, having such a figure in mind, there is also one thing we need to identify, is that whenever I told 1 Faraday is equivalent to 96,500, it means that 1 Faraday is equivalent to 1 electron. It therefore means that 1 electron gives 96,500 coulombs. How about this 290,000 coulombs? Therefore, I will have this one. I'll ask myself this very simple question. If 96,500 coulombs gives me 1 Faraday, which is equivalent to 1 electron. How about 290,000 coulombs? Now that will be 290,000 times 1 divided by 96,500 coulombs. So if you punch that one in your calculator, you will get 3. Now, since Q is a metal, metals react by losing electrons, and when they lose electrons, they acquire a positive charge. It therefore means that the charge should be equivalent to positive 3. If we were asked to write the formula of the ion of Q, we would write Q3 plus. So those are some of the very simplest ways that you can approach such a question. Secondly, we've been asked this very other simple question. Calculate the volume of the gas that is produced. How do I calculate the volume of the gas produced? First, I must write the equation for the reaction. Whenever I'm having a sulfate of Q, it therefore means that the formula of the sulfate will be Q2SO4 3, where 3 is this one when they exchange their valencies. So 3 is the value and 2 is for sulfate. I hope that one is very clear. So as I said earlier, this is the formula of the sulfate. When they exchange their valencies, that will be the formula. So yesterday we talked about some of the very simple ways to know how the ions will be preferentially discharged. In this case, if I have the aqueous of this thing, I'll have Q3 plus hydrogen ion, sulfate 2 minus hydroxide ion. And clearly I stated that hydroxide ion will be preferentially discharged because it is below the sulfate ion. It therefore means that the formula for the reaction to produce oxygen gas will be very simple, and this is how we will write the equation for the reaction. It will be 4OH minus aqueous to give me 2H2O liquid plus oxygen gas plus 4 moles of electron. But also keep it in mind that 1 Faraday is equals to 1 electron. It therefore means that in such a case I will have 4 Faradays or 4 electrons. So how do I calculate that one? First, I will get the quantity of electricity that will be produced by 4 moles of electron. Remember, 1 mole of oxygen gas is produced, and 1 mole of oxygen gas is 22.4 decimeter cube. So I'll say 1 Faraday is equals to 96,500 coulombs. How about 4 Faraday? 4 Faraday will be 4 times 96,500 coulombs divided by 1. So when you punch that one in your calculator, you will have 386,000 coulombs. 386,000 coulombs. So this 386,000 coulombs produces 1 mole of oxygen, and 1 mole of oxygen is 22.4 decimeter cube. But again, keep it in mind that a current was passed 200 amperes for 58 minutes, and if it was passed, what was the quantity of electricity? It was 696,000 coulombs. So I can equate this one to this one, then I get the value for this one. So how do I calculate it? I will now say that if 386,000 coulombs gives out 1 mole of oxygen, so molar gas volume means that 1 mole of a gas at STP occupies 22.4 decimeter cube. That is why this quantity of electricity produces this amount of oxygen in terms of volume. How about this charge that is given out. So it will be 696,000 coulombs. So it will be 696,000 times 22.4 divided by 386,000. So when you punch that one in your calculator, you will have 40.39. So the answer will be 40.39 decimeter cubed. But again, remember, 1 decimeter cube is equals to 1 liter. So I can as well say it is also equivalent to 40.39 decimeter cube. And that is how simply we can approach question 1. Now let us get to question 2. It is another very simple question to tackle. We've been asked, what mass of zinc will be deposited from a solution of zinc chloride when a current of 3 amperes is passed through the solution during electrolysis for how many minutes? 50 minutes. The first thing, as I said earlier, write down whatever you've been given. What are we told? That the current I is equals to 3 amperes. Time is equals to 50 minutes. And I must convert it into seconds. So what will be the answer? The answer will be automatically 3,000 seconds. So from there, I can calculate the quantity of electricity that will be produced when a current of 3 amperes is passed through for 3,000 seconds. So Q is equals to IT, which is 3 times 3,000. That will give me 9,000 coulombs. I hope that is very clear. Secondly, when zinc chloride has been electrolyzed, zinc metal will be deposited. So I must write the equation for the reaction. And this is how I'll write the equation for the reaction. Zinc ion will undergo what is called reduction to form zinc metal. So zinc metal will be deposited. Therefore, having that in mind, how many Faradays are being used? 2 Faraday. But keep it in mind, 1 Faraday is equivalent to 96,500 coulombs. So I can simply ask myself that question. If 1 Faraday is equivalent to 96,500 coulombs, how about 2 Faradays? It will now be 2 times 96,500 coulombs. So when you punch that one in your calculator, you will have 193,000 coulombs. So I have such a figure in my mind. Now, this 2 Faradays gives me 1 mole of zinc, and 1 mole of zinc is 65 grams. Remember, when I tell you zinc is equals to 65, it means that that is the molar mass of zinc. 1 mole of zinc occupies, not really occupies, but is equivalent to 65 grams. So that is the same question I'll ask myself. This quantity of electricity, 193,000 coulombs, produces how many grams of zinc? 1 mole of zinc, which is 65 grams. How about this quantity of electricity? 9,000 coulombs. So it will be 9,000 times 65 divided by 193,000. So when I punch that one in my calculator, I will get automatically 3.0031 grams. So that is the mass of zinc. Thank you. That is all for today. I hope we will meet in the next electrochemistry class. Bye.